Hi everyone, welcome to the course. Today we'll start with the first content. So we had a view earlier on what this course consists of and what you can expect. And now we want to dive today into the very foundations. So we learn the necessary terms and tools today so you can understand the remaining lecture and participate in it. So today will be all about the foundation. And speaking of foundations, there are two things that are important for me as of today. First one is you becoming familiar with the terminology. In particular, what do I mean when I talk about artificial intelligence? What's my understanding of terms around machine learning, statistical learning, but also why do I think is it important to have a system-oriented view, or the term of systems thinking, as you can see on this slide. And on the other hand, I want you to get a first understanding of the AI lifecycle. So the typical process that you have when you develop AI models and also deploy them later in the setting, right? So pretty short overview. That's what we want to achieve today. Let me start by shortly highlighting a few organizational aspects here. When we look at the course, I tried to have an content-oriented view in the way that we structure it, right? So you can see we start over here with the foundations, which is today's lecture, which again sets the terminology, makes sure you have an understanding on why do we deal with the topics that we deal with as part of this lecture. And then we will dive into the AI lifecycle. So we will follow this logic of initiating an AI model, then building it, determining its performance, deploying it in the field, and then finally dealing with changes in the environment, in the setting where it is deployed, monitor those changes, and make sure that the model also works over time. And with that at hand, we'll make a little shift, because then we do not talk about designing AI in an isolated space, but designing AI in systems where we have multiple stakeholders, multiple agents collaborating with each other. And when we move to this domain, different aspects become important. It's about using foundation models to generate value. It's about ways on how to learn across different legal entities in the area of system-wide learning. And then, of course, finally, what if one of these agents is in fact an AI and the other agent is a human? So how does human AI collaboration work, and what are current research objectives and ideas here? And then finally, to be very honest, because it didn't fit into all the other sections over here, I want to talk about two things that are dear to my heart. One is creative AI. So what are means that we can make AI creative? Where are we there currently? And then finally, AI ethics and fairness, where also a bunch of my research is concentrating on, right? So that's the story of our lecture today. And the way that we do that is we have these online lectures, the one that you are watching right now, which you can and should watch then before we meet in person. For those who will meet in person, those that are only participating online, there are different ways of participating. But we'll do these online lectures, and then once we get the chance to meet in person, we will pick out different aspects, potentially interesting phenomena or challenging questions, or also provocative statements that I potentially made here, and we then want to discuss them in class whenever that is possible. Awesome. Now, with those organizational aspects at hand, let us dive into the first content, which is my view on artificial intelligence and machine learning. So obviously, two terms are important when we talk about applied artificial intelligence. Two terms that I will also frequently mention, and I think it's worth starting with the definition or my understanding of these two terms. On the one hand, we have artificial intelligence, and on the other hand, we have machine learning. And let's dive into what do I mean when I talk about these two terms. A more general question, though, is why do we talk about AI? Why is there such a hype right now? What is the business perspective on that? And you can see two headlines here, one from The Economist and one from The Washington Post, both about the potential of AI to transform businesses, or as you can see on the left, on enabling businesses. So why do we talk about AI? Because we do believe that there's a fundamental change happening once we utilize AI to its fullest potential in organizations. And a long time it was seen as a theoretical potential that is there, but right now we see more and more cases on where AI actually does deliver value, right? So even if we don't care about research, coming from a practical perspective and having that view on AI, apparently there is something to it and it's worth investigating. On the other hand, if we look from a research perspective, there are a bunch of papers, obviously, on AI and applications of AI. I think right now, like every day, 100 new papers are being published related to AI. So no one in the world can read that. Of course, me neither. But what's important here is, I think, to stress that there are different domains where AI can make an impact from a research perspective, right? You can see medical one over here on the left side, right? So where advances in AI and machine learning help in predictive medicine. You can see aspects in the environmental field where a lot of progress is attributed to successful AI applications. Again, interesting fact is that this is also a dual sword, so there is also a lot of concern about the energy consumption that AI has, but that's a point that we'll get into later. And of course, also the social implications of AI play a major role. And across the field of research, you can find even more papers motivating that. So apparently, there are good reasons to talk about AI from a business perspective, and there are good reasons to talk about AI from a scientific perspective. But the question remains, why do we talk about it right now? And the reason for that is not only ChatGPT, right, which is the most common AI tool that people might use, but it's way bigger than that. And that's also an important point for me to make in this very course, is that AI is not ChatGPT. ChatGPT is one important example, but also one very specific one. The field of AI is way broader. And if we look into the future of jobs, the future of works, especially in AI-related roles, you can see this is of very high importance across different fields for today's companies. There's this nice McKinsey study which looked at the roles that are being needed in the future. Roles like you can see over here, like machine learning engineers, AI data scientists. And you can see that hiring these people is perceived as very difficult by companies in that report. So obviously, going into the AI space is a good idea if you're interested in a nice and bright future, job-wise at least. And on the other hand, you can see the value that is being driven. Also a McKinsey study over here that estimates the total economic potential of AI in trillion US dollars, right? And you can see it going up to more than 25 trillion US dollars of total economic potential, which is really impressive. And that's why now is especially an interesting time to deal with these topics. However, I don't want it to seem like all the problems are solved here. In fact, there are a bunch of challenges when it comes to applying AI. And that's also something that we want to find out together as part of this course, right? I want to put the finger here and there on important topics where the clash between what's theoretical possible in AI and what is delivered in its applications, make sure there's a gap and there's still stuff that needs to be done. So if we look at a few challenges that we have when it comes to the application of AI, and by the way, we'll address all of them as part of this course, a very common one is bias in data. I'm getting ahead of myself, but in a nutshell, biases in data will lead to biased AI models. And you can see this exemplary quote here from the article about how AI can be, I'm just reading it out loud, racist, sexist, and creepy. So what should we do about that? Huge challenge in the field. And like hundreds of researchers working on that, but it still does remain a challenge, which we'll see by the end once we get to the AI fairness and ethics lecture. Second, labor conditions. So there is evidence, hard evidence by now, that the AI boom is a dream for many companies, especially in Western countries, but is a nightmare for workers in the global South. So it does challenge the way we work, and especially the way people work in the global South and the typical roles and jobs that they would take. And that's also something, again, that we will need to discuss in the end when it comes to AI, ethics, and fairness. And again, also sustainability, I mentioned that already on the previous slide, is while we have many benefits of this AI boom, its carbon footprint is, to say the least, challenging or even questionable. So the emissions that are caused by AI are an important thing to have on top of your head, right? So there's a bunch of things to do. And it doesn't stop there, because there are also a lot of challenges when it comes to humans utilizing AI in their professional or private lives. And that's already one of the key messages that I want to place today, is the idea of the appropriate reliance. So how reliable and how safe is AI? You can see a bunch of examples over here where it went wrong. Something that we also tried to address in a recent research article, which deals with the idea on how, if and when we can and should rely on AI advice. So in a nutshell, how can we make sure that using AI is beneficial to us as humans? But the assumption here is that we can identify errors that the AI makes and then override those errors. This idea of human oversight is unfortunately in many ways flawed, right? What I want to say here is that even if we design the best technical systems, these will be deployed within organizations or within socio-technical constructs. So the human factor remains important. And one of these factors is especially the humans appropriately relying on advice that has been given by AI. But we'll dive deeper into that once we come to human AI collaboration. So you can see there's ample motivation for why we should deal with AI from a business perspective, from a scientific perspective. And there are also many, many challenges. And I just named a few over here. So I think it's worth investigating. But before we can do that as part of this course, the question is, of course, what do all these terms mean that I keep throwing around now? You've already heard the term of artificial intelligence now a few times. And there are many viewpoints on how the different terms are related to each other. But let me give you for now my view, and please challenge it, right? There's no absolute truth in that. But if we go back in time, like very far in time, you have this idea of mathematics and statistics, of identifying patterns in data, mostly in numeric data back then, right? But to be honest, that's the origin of everything, right? Utilizing data, finding patterns in data. For example, with simple methods like a linear regression, a logistic regression, decision trees, and so on and so on. And that's the origin for everything that we do today in the AI space, is basic mathematics and statistics. And that's also where the most important foundations were being laid. However, as we move forward in time, so coming into the 70s and 80s of the 20th century, you could see a new discipline developing, which is called machine learning. And the origin here is computer science. Again, computer science and mathematics and statistics are closely related, but over time, computer science became its own discipline, you could say. And the idea of machine learning at first was to implement the methods that came from the statistics departments. So implementing, for example, a linear regression within a program that could then be applied to the data that you have at hand. So machine learning is definitely derived from and inspired by mathematics and statistics. However, I have to say that over time, this became more and more of an independent field. And one of the areas where you can see that is this whole idea of deep learning. While, of course, this is also based in statistics, you can say, I think, that the deep learning community is more rooted in the computer science world than in the very, very traditional mathematics and statistics. Although I have to say, like, the idea of neural networks is also very, very old, and again, comes from here. So it's hard to distinguish, but you will hear in many cases the words of statistical learning and machine learning. And to me, machine learning is derived from, inspired by the traditional statistical learning, but there are also a few things that really originate from this area. And then we have artificial intelligence, which is some kind of instantiation. We'll come to that in a second, what that is, but artificial intelligence applies a bunch of methods from this method set. It can apply methods from machine learning, so very modern things like transformer-based neural networks, for example, very traditional things, and also, of course, many, many other methods that I don't even talk about in detail, at least not yet, like natural language processing, image recognition, logical reasoning, in general, computer vision closely related to that. So the instantiation of artificial intelligence will always apply these different types of methods, which come from different disciplines. That's the one side. The other side is the application. So if we talk about data mining, for example, it means the process of applying these methods over here, right? So an AI agent, to use the term, is something that is deployed within the real world that does make decision or recommendations. Data mining, on the other hand, is an activity that I could do as a data scientist, right? To find patterns in data, to predict something. And of course, there's not only data mining, there are also specifics like text mining if you work with textual data. So that's my world and my understanding of what these terms mean and how they are related. Again, there's no absolute truth to that, but it helps me at least to a little bit structure and digest the ideas here. Okay, let's move on. Now, I talked about AI being an instantiation, but what really is AI? And I have a favorite quote here from Mark Zuckerberg, the Meta or Facebook head. It's a few years old, but I think it's interesting and still holds true as a good example. So Mark Zuckerberg had a US Senate hearing in April 2018. And there were a bunch of topics there, but one of them were Facebook's tools. And he specifically said, and this is a direct quote, that Facebook uses AI tools to identify hate speech or terrorist propaganda in the data that they have at hand. And to me, it's not interesting in how they do that precisely now and what kind of data Facebook has. What's interesting to me for our debate right now is, what does the AI tools here mean? Because a scientist from a different field, for example, from statistics, would be very skeptical about what does AI mean here. I mean, identifying hate speech or terrorist propaganda is a very traditional supervised machine learning task. So is Mark Zuckerberg really talking about AI here or not? And that's something that we want to answer in the next questions. Not questions, but in the next slides. And then in the end, we will pose this question again. But spoiler alert, there's no clear answer to that. So there are different views on AI. You might even say schools or viewpoints. And I want to go deeper into all three of these. The first one are different research currents. So different scientific viewpoints on what constitutes important aspects of AI research. They're not necessarily conflicting, they just look at different ways on how to think about AI. Then there's the second one, the second definition, which thinks of AI as an agent. So agents being the central instantiation of AI. And then there's the third definition on AI, which looks at the level of intelligence that is implemented. So how we can differentiate AI by its cognitive abilities. But we will first start with the different research currents. And here we have a 2x2 matrix. One looks at the kind of decision making, which is the objective of an AI. So is that something that is targeting a human-like decision? So being like a human, and we know humans are flawed, so we do make mistakes. We don't always make the rational choices, but implementing an AI that will make decisions like a human does is this objective over here, the objective to be humanly. And then we have, on the other hand, the rational decision making, right? The ideal decision, the objectively true decision, right? Apart from emotions that typically drive as humans, but something where you can say that is objectively true. So that's the one dimension where we can differentiate the objective of AI, humanly or rationally. And then the second dimension is where we apply this to the idea of thinking. So how does the AI think? Do we want to replicate this as being very humanly or rationally? And then the other one, how is the AI acting? And if we combine those dimensions, we get a very nice 2x2 matrix with 4 different research currents of AI. The first one being cognitive modeling, which is the combination of thinking in a human way. And this research current is called cognitive modeling. So the stream of cognitive modeling is about an AI being a machine with a mind, performing human thinking, not only based on the same output as the human when given the same input, but also on the same reasoning steps, the same logic that we as humans work, so that it comes up with a very conclusion. So it's about thinking the way humans do. So how, in a nutshell, how can we model our cognition, our brain in the end? And that's one research stream. Well, if you can think humanly, then you can also think on the other end rationally. And that is the laws of thought school. So it's about thinking rationally, which says that an AI thinking process needs to arrive in the end for its decision at the rational choice, despite what a human might answer. Again, we as humans, we are very flawed in how we think and how we make decisions. So different idea. Sometimes conflicting, sometimes the same as a human thinking. Now let's move one dimension down. Now it's not about how AI thinks, but how AI acts. And a very famous school here, a very famous research current, which you might be aware of, is Turing, and specifically the Turing test, which is about acting humanly. So to read it out loud, an AI must act intelligently when interacting with humans. Therefore, an AI must perform human tasks at least as good as a human does. So this can be tested by the so-called Turing test, where you set a person in front of some kind of interface, could be even like a humanoid, and then if the human can't figure out after a certain type of amount of interactions whether he or she was interacting with a real human or with some kind of synthetic human, or in our case AI, then this AI would have passed the Turing test. So it tests whether the acting of a synthetic being is human or not, and if a human can distinguish between that. There's a really great movie about the Turing test, which I would highly recommend to you. It's called Ex Machina. By the way, it's a good movie, but it's an entire movie about the Turing test, about a very modern Turing test. So if you get the chance, please watch it. It's a very nice entertainment version of what I'm talking about here right now. And then finally, we of course have the combination of rationally acting, which is the rational agent theorem. So an AI acts as a rational or intelligent agent, which means this agent acts autonomously and always arrives at the ideal outcome. And again, what changes here is that before it was all about, when we talk about the Turing test, it was all about mimicking the human as good as possible. And now it's about acting in a very rational manner. Okay, so we could dive hours into these different research currents, but right now it's important for you that you're aware that they exist and how they differentiate. So next, let's get into a different definition of AI, which is the agent-oriented view. And this figure over here is a very nice depiction on what defines an AI agent. Again, this is one view on how we can look at AI, but to me it makes a lot of sense. And it is not necessarily tied to AI. In the past, you could talk about agents that were not AI enabled at all, but they were just agents. And the agent theory has a certain understanding on what the world looks like. And that is the following that you can see over here. So we do have an environment where we place an agent, right? So that's the one over here. And what the agent needs to do now, it needs to perceive this environment via sensors, get an understanding for what is the world like right now. So what is the current state of the world? Then do some kind of calculations, now based on machine learning models typically, and then decide on actions that need to be done to change that environment. And then it also needs actuators on the other hand, which perform actions and potentially change the environment. So what you can see over here is, on the one hand, it's this circular relationship, right? Performing actions on the environment, thus changing it, and then again perceiving the state of the environment and then making new decisions based on that. So it's this circular relationship on the one hand. And on the other hand, you can see that two aspects are of importance here, because every agent needs sensors and actuators. Sensors to perceive, to sense the environment, and actuators to influence the very environment. And that's really, really important. And again, that's potentially something that can happen apart from any AI thoughts, and it has happened in the past, but I think now it makes a lot of sense. And what you can already see here is that it's this idea of autonomy, an autonomous agent being deployed within an environment and then making decisions on its own and also influencing and potentially changing that environment. And I think that makes a lot of sense for AI. To be more precise, there's this so-called PEACE model, which helps you to structure any given agent. So PEACE stands for performance measures, environment, actuators, and sensors. You can see the actuators and sensors here again. And let's go through an example. For example, this agent is a taxi driver, potentially an AI-based taxi driver, but it could also be a human taxi driver. And the PEACE model helps us structuring our agent and better understanding what it can do. So we have on the one hand the performance measures, the P. So things like how safe is it, how fast is it, how legal is it, are the trips comfortable, does it maximize profit, things like that. So KPIs in the end, performance measures. Then we have the environment influencing this agent. It's the environment where the agent again perceives it continuously and also acts upon it. This is obviously the roads where the taxi is driving on, other traffic, pedestrians, customers, and so on and so on. And then the two technical components that are of importance here. On the one hand, the actuators, so steering, accelerating, braking, signaling, horning, displaying, and so on and so on. And then the sensors. In the case of a synthetic agent, things like camera, sonar, speedometer, GPS, accelerometer, and so on and so forth. And all of this together really helps getting a nice overview on what constitutes an agent and potentially also an AI-based agent. And that also really, really helps me when I think about AI agents and what they're supposed to do. Okay, now let's come to the final definition of AI. And that is an intelligence level-oriented view. So earlier we tried to distinguish AI by the different research currents or by whether or not it can be seen as an autonomous agent. Now we look at a different characteristic of AI, which is its intelligence. And once we dive into that, obviously you will ask, wait, what is intelligence in the first place? And of course there are a bunch of definitions on what is intelligence, but I really like that one. Intelligence is the ability to perceive information, to retain it as knowledge, and to apply it towards adaptive behaviors within an environment. So let's say that is our definition of intelligence. Now, where does AI come into place here? Well, we don't have to look at AI at first, but let's look at any biological being out there. And in the field of biology, there are different terms that describe intelligence, but one of the favorite terms that biologists have is cognitive capacity. And there are a bunch of ways on how you can measure that, but a very good proxy is you take the mass of the brain of a biological being and set it in relation to the entire mass of that biological being. And that gives you a good quota, gives you a good proxy for the cognitive capacity, or so to speak, intelligence of that being. And of course, researchers have done that in the past. So we have kind of a hierarchy of intelligence here across all the biological beings best to our knowledge, of course. And on the very left over here, you have the goldfish, then comes the mouse, then the dog, then the whale. So cognitive capacity is rising. Then comes the monkey, and then finally, again, to the best of our knowledge, us humans. Now, let's take this figure over here also to distinguish between different levels of AI. So if we move it, again, to remind you, this is a biological range of intelligence, we can now differ between different levels of AI. On the bottom left, we have weak AI. Weak AI is good at one very specific thing. These are most of the traditional examples that we had when it came to AI, like playing chess, right? Like calculating certain routes in optimizing traffic, things like that. One important aspect of weak AI, though, is that it's good at this one specific thing. It can be even better than humans in doing that, right? So an AI classifying pictures in radiology better than all the radiologists is still a weak AI by definition. An AI being better at chess than the grandmasters is still weak AI because it's only good at that one very specific thing. Again, can be potentially better than humans, but only in this very niche task. And the majority of AI that we see, nearly all of it right now, falls into that category. But as you can see, the graph doesn't stop here. So there's the next level called strong AI, or also nowadays often called AGI, artificial general intelligence. And that is AI as intelligent as a human. So across all of our characteristics, not only being very good at analyzing large corpuses of data, but also having creativity, social skills, empathy, right? Being as intelligent as we are across all of what makes us human. And we're not there yet at this stage, but that would be the next level. But as you can see, the graph doesn't stop here because we as human beings are, of course, limited in what we can achieve, simply the way that we are designed with all our flaws, right? I mean, our brain cannot get any bigger than it is, and it already took us a few million years to get to our current state. So we are limited, but AI is not. I mean, the only limit of AI is, in the end, the hardware power that you assign to it. So, of course, there's a level after strong AI, which is called artificial superintelligence. And I really like Bostrom's quote here because it describes very well what artificial superintelligence is. It's much smarter than the best human brains in practically every field, including scientific creativity, general wisdom, and social skills. And artificial superintelligence is anything over here that is slightly more intelligent than the smartest human on Earth, right? A little bit smarter than Einstein. But it is also up here. So 7 Earths of intelligence combined. So super intelligence, as you can see from the term. And again, this is, of course, right now a theoretical concept. We don't know when and how and where we will get there. Again, something that we'll also discuss in the ethics part. But I think it's important to also have this perspective on AI. Now, with these 3 different definitions being said, let's have a look at machine learning. And to understand what role machine learning plays in artificial intelligence, we have to go back a step first and talk about what are the different types of machine learning. And again, there are many, but let us focus on the most important 3. The first one is supervised learning. And this makes up about 95% of all the cases that you can currently see in research and practice. Supervised learning is all about learning the mapping from the input to the output. And typical cases that you can see here are regression or classification problems. This now sounds very theoretical, and we haven't even talked about regression and classification yet. So let me give you a very simplified example, because what I really like about machine learning is that it's very similar to the way that we humans learn. I mean, to be fair, our machine learning methods nowadays are largely influenced by how we humans learn. So many of these methods are inspired by how our brain works with a biological neural network, for example. But to give you an example on what supervised machine learning is about, I always like having a child because in the end, children learn very, very, very similar. And so let's take a child over here. We want to teach the child something. Let's say it doesn't know anything about the matter at hand. And what we want to do here is we want to teach a child something about cars. Let's take toy cars as an example here. And so we give the child a bunch of toy cars and we cluster it into two different cases, two different targets, you could say. We have a bunch of toys which are sports cars, and we have a bunch of toys which are SUVs. And we tell the child that. We say, look at those 5 cars, they are sports cars, and look at those 5 cars, they are SUVs. Obviously, those two have distinct properties, but we do not tell the child what it needs to look for. We just say, here are examples of that class, and here are examples of that class. That's what we call, by the way, a binary classification task or binary supervised machine learning task. And then the child will look at these cars, it will look at the properties, and will find out by him or herself what distinguishes these two, right? It will see, oh, okay, apparently sports cars seem to be flatter, SUVs seem to be higher, right? It will look for properties separating these two. And again, that's what happens in supervised machine learning. We give the algorithm a bunch of data and we tell it what our classes are, in this case, sports cars and SUVs, and it will figure out on its own what the differences are in these two cases. So now if I give the child a new car that it has never seen before, it will always think in these two classes and will assign this new car based on the properties and patterns that it identified earlier and say, okay, this is either a SUV or a sports car. So you see, in supervised learning, there's always a clear output, a clear target. And in the case that we had over here, it was SUVs and sports cars. Now that's not the case in unsupervised learning, because this is about identifying previously unknown patterns in the data. So typical cases are clustering or association rules. Let's take the same example that we had earlier with a child. Now, again, we want to let the child sort toy cars, but now we let the child determine him or herself how to arrange or cluster them, right? So we give the child a bunch of cars, and now the child will have its own logic on how to arrange them. It might arrange them by its personal liking. It might arrange them based on the color or the shape of the car. There's not necessarily a right or wrong, and then in the end, it will have created some kind of logic on how it clustered the cars. That is unsupervised learning. So there's not necessarily a ground truth here. It's just different children could come up with different solutions, which also makes it very hard in the real world to evaluate whether unsupervised learning was successful. There are metrics though, like silhouette coefficient and stuff like that, but still, because there's not necessarily a truth behind that. There are just different patterns that you can identify in the data. And then we have a final type, which is called reinforcement learning, which you might have heard before, which is very closely related to the agent theorem that we just covered. Because in here, we kind of have this agentic view. And reinforcement learning is all about getting feedback, so rewards or punishments on actions being taken. To take the example of the child again, now, similar to supervised learning, the child picks a toy car and labels it. So that's an action. So it could say, oh, this is a truck or a passenger car, or like earlier, a sports car and SUV. And it will get a response from his parent or her parent then, a reward in a positive manner, saying, okay, yes, you are correct in that way, or a punishment, which sounds very hard in the example of a child, but deny that. And by the way, reinforcement learning is very much how our brain, how our neurons work in the first place. So it comes very natural to us. So over time, this agent, or in our case, the child, will learn which actions lead to a positive reward and will try to increase those. And it will also learn, on the other hand, how to avoid cases where his or her actions lead to punishment. And that means over time, with more and more data, it will learn the patterns that are of interest to the child. And so these are the 3 types of machine learning. How does it now tie into our AI idea? I picked up the logic from the agent-oriented view and put it into this figure over here. Let me run you through it very quickly. Again, we have the environment that we talked about. So we have the sensors and the actuators, and via both of them over here, the agent can both perceive the environment and also act upon it together with its so-called front end, which is a term that comes from software engineering mostly. And of course, we have the knowledge of this agent, so where it stores any information on the patterns that it discovers. That was the one definition that we had. Now we combine it with the capabilities of thinking and acting that we had earlier. So if we think about capabilities that we as humans have, this agent needs to act on the one hand and also needs to think. And we can further distinguish this thinking into learning new knowledge and executing on existing knowledge. And this gives us two definitions of potential agents. The one agent is a simple reflex agent that somehow built knowledge in the past. We don't know how. Potentially the engineer gave it to the agent. And now it executes continuously on this existing knowledge. So it makes decisions and then communicates them via the front end, and then the actuators will act upon the environment. The more interesting case for us is the learning agent, which has a learning backend, where it can continuously learn new knowledge by potentially reading the environment, just like we had earlier in the example of the reinforcement learning. And this learning process can happen via a bunch of different methods. You can have very simple rules or formulas, or you can have a machine learning model. And this is the role of machine learning, from my point of view, in AI, is that it is one possibility for an AI to learn and also to execute on that learned knowledge by utilizing that model. But it's only one way. In theory, there could be other ways on how AI learns and executes on this learned knowledge. But that is the role of AI. That's the role of machine learning in AI. Is it enables the AI to build up knowledge and then make decisions based on that knowledge. So AI and machine learning are not the same, right? I think that's my important message over here. Machine learning is a set of methods that enable learning and also executing on that knowledge. AI, however, is, in my logic here, an autonomous agent that is implemented within a real-world environment where it can make recommendations and decisions, but it belongs way more to AI than only machine learning. And again, in theory, there could be AI without machine learning because the AI requires sensors, actuators, and everything that you can see over here. And again, this categorization really helps me in understanding the role of machine learning in intelligent agents. So now that we covered all these views of AI and also covered the different types of machine learning and the contribution of machine learning to AI, I think we can come back to the question whether Mark Zuckerberg was right in calling these tools that I identify hate speech or terrorist propaganda and calling them AI tools. And again, there could be different views on that, right? If you come from a very traditional machine learning perspective, you would say, well, identifying hate speech is just binary supervised machine learning. And that's a fair point to have. On the other hand, you could say, well, there were potentially actuators and sensors involved, so it could be as well AI. But that's something that we can discuss in class if we get the chance to do that. Now let's talk about another perspective that I want to have in my course. And two terms we cleared already, AI and machine learning. Now let's have another viewpoint to make it even more complicated, but you'll see why that it's important in a second, which is the systems thinking. And that prompts a question on what are systems, or especially what are service systems, because Jim Sporer gave a very nice definition of that. So service systems are comprised of service providers and service clients working together to co-produce value in complex value chains or networks. So it's about creating value in a network. And to have a very nice graphic on that, that means on the one hand, you have a service provider A, which serves a service client, but the value co-creation can only occur because we have this complex systems of different providers and clients working with each other. And also these roles can be interchanged, right? Sometimes one of these clients can be a provider and vice versa. My important message over here is that value is being created by collaboration here. So multiple entities, stakeholders, work together, and by working together, they create value. And I think that's a view that we need in AI, because AI is not implemented into a space where there's only one entity, but it's implemented in these multi-entity or potentially multi-agent systems where value can only be created, because that's how our world works right now, if multiple parties collaborate with each other. And that's why I think it's so important to have a view on that. And that's why we also will get later into what does it mean for AI design when we have that systems thinking at hand. But I want to give you an example, because this is very abstract and conceptual here, what I mean with systems thinking or with service systems in general. A nice example that I always do is cleaning a car, because value can only be created here if the customer brings his or her own resources, in that case the car over here, and the provider also brings things into the equation, like the car wash itself, the staff, the commodities. And only if those two come together, value can be created. Now, that's a very traditional service, or in this case, service system. So let's have a look at a more modern one. Because we have the same logic in smartphones, right? You have multiple different stakeholders that co-create value, and only because they work together, value for the customers can be created. So we need someone producing a hardware smartphone, right? Only if we have a hardware producer for that, it works out. That could be one player, for example, Samsung. And then you have another player which provides the operating system, which comes in the case of Samsung, at least more or less, from Google's Android. And then on top of that, you have application providers, for example, TikTok. And then TikTok itself only works because many customers work on that single platform. And only because all of these customers share their, in this case, data, videos, value is created. So you can see it's a complex system of multiple stakeholders, and only because all of that works together, value is created for the customers. But you see that we have many levels over here. So if you're interested in this way of thinking, the systems thinking, there's a textbook out now from KIT on the fundamentals of service systems, and also from myself and my colleagues Maria and Philip on managing these smart services. Okay, now this brings me to my final message today, which is the AI lifecycle. And that structures the remainder of this course. And for the next lectures, 3 things will be important. The question on how do we start? How do we set the foundations? How do we understand our data? That is called the model initiation. And when I talk about model, I always mean machine learning model, the motor of our AI. So in the next lecture, we will talk about how do I get the right data? What can I do with that data? How can I understand it to then have later the best possible machine learning model? The second step in this life cycle is the performance estimation, which is all about building a model that performs well on previously unseen data. And for that, you utilize 2 steps. The one is the model training, where it learns pattern on the data. Remember the example that we have had of the child, right? When we give the child 5 SUVs and 5 sports cars, when the child learns that and observes the distinct properties of these cars, that would be called our model training. And then we have model testing, again, where we apply the model to unseen data to see how well it does. So again, we give the child the car and see how well can it predict what type of class this car belongs to. And then once we're happy with these results, once we have a model where we think it captures the patterns of the real world, then it's all about deploying this into productive systems. So the third step, model deployment. And that will be the logic for the next upcoming lectures. One thing I want to notice here also is that for the next lectures, we will focus on problems in supervised machine learning. I think I said that earlier, but supervised machine learning makes up 95% of the cases that we currently see in research and industry. And we will also, so we will keep the supervised machine learning logic And we will always think about how can we incorporate this into intelligent agents. So we will adopt these two views, supervised machine learning and intelligent agents. I will make a few examples here and there about other cases, but I think these are the most interesting cases. So to talk about agents that use supervised machine learning, and you will see how powerful supervised machine learning is as this course continues. So that's it for today. Thank you so much for listening. I'm really looking forward to the discussions, and see you soon when we talk about the model initiation. Bye-bye.